to equation A, okay, we know that B is equal to 0 and A is equal to 1, right? If you look at our equation, our A is equal to 1 down here, basically. So beta now will be equal to minus 4C divided by what? Divided by 2. Okay. So we are going to, because it's impossible to do a square root, so we are going to let omega will be equal to square root of 4C divided by 2. So when that's the case, omega is equal to square root C. Okay. So finally, we know that based on d squared y over dx squared plus by our py over ei, this is equal to what? 0. So before we go any further, we are going to let small p, okay, or small p squared, okay, is equal to big P over EI. Okay, we're going to let P squared. Okay, so when that is the case, right? When that's the case, the equation now will become, so this is our equation A. Okay, we're going to, let me write down, let okay, now this is small p, not capital P. You can see that it's with the line. Okay, the P is on the line, the other P is above the line. Okay, so let P square equal to P over I, and we're going to substitute. Okay, substitute into A. So we have d squared y over dx squared plus by small p squared y, and this is equal to 0. This is our equation B. Okay. So therefore, okay, so therefore, a general solution, okay, so therefore the general solution will be y as a function of x is equal to c1 sine px plus by c2 cos px. Okay, so that is our general solution. Okay, so that is our general solution. So our general solution, we are going to call it C. Okay. Now to make the solution unique, okay, we have to now consider our boundary condition. Okay, like what we have done with elastic curve. Remember, now we have to bring back our boundary condition, so on and so forth. So we come back to here. Okay, we have done, where did we draw boundary condition? Yep, this diagram over here. Okay, so now we're going to take this thing over here. Okay, you know what? I'm going to take the whole thing. We're going to okay. We'll take the whole thing. Okay. So we know that y as a function of x will be equal to c1 sine px plus by c2 cos px. And that is our equation C. Okay. Just to note that P, small p, is equal to square root of big P over EI. Okay. Where P is the axial compressive load inducing the buckling. Okay. Because we're going to substitute. So we look at the boundary condition number 1. We're going to substitute when x is equal to 0, y is also equal to 0. Okay. So this is equal to 0 is equal to C1 sine P multiplied by 0. Okay. And then, oh, this is bad. So sine P0 plus by C2 cos P0. Okay. So we know sine 0 is equal to 0. Okay. Cos this is equal to 1. So therefore, C2 is equal to 0. So from here, we can write up the expression knowing that C2 is equal to 0, y as a function of x. This will be equal to C1 sine px. Okay, because C2 is equal to 0. Okay, so this is our equation D now. Okay. So after knowing our equation D, we're going to substitute our boundary condition number 2. So boundary condition number 2 states that when x is equal to L naught, y is equal to 0. Okay, so when x is equal to L naught, okay, y is equal to 0, and this will be substitute into equation D. Okay, so we have y. So I'm going to put x to be our L naught down here. So you have C1 sine P L naught. And we know that this thing is equal to 0. Okay. Okay. So the next thing that we ask ourselves, okay, now, what are we actually interested in? Okay. What are we interested in deflection? And the answer is no, we are not actually interested in deflection. We are interested in what force, okay, will cause the will cause buckling. Okay, so I know this is late, but bear with me. Okay, we are not interested, unfortunately. Okay, deflection y is not of interest. Okay, what we want, okay, what is of interest is the p-value where buckling will occur. Okay, so i.e., what is important is this thing down here, capital P. Okay, so anyway, we have no choice. We have to start working with this. Okay, so the next thing we ask, in what condition where sine PL0 will be equal to 0, right? In what condition it will occur, right? So we know that the only thing that this will happen, so sine of 0 is 0. Sine of pi will be equal to 0. Sine of 2 pi will also be equal to 0. Sine of 3 pi, some of you will say, will also be equal to 0. So P or sine PLO will be equal to 0 when PLO is equal to pi, okay, or n pi, where n can be equal to 1, 2, 3, 4, so on and so forth. Okay, so when that's the case, we know that small p is equal to n pi over L0. That is small p. Okay, so this is our equation number E. So we are going to substitute small p is equal to square root of p over EI into our equation E. Okay, so we have our square root p over EI is equal to n pi over L0. So if we were to rearrange this equation, we have p is equal to n squared pi squared EI over L0 squared. Okay. Before I end for today, remember, in centric buckling, P critical is equal to pi squared EI over L0 squared. So we are almost there. Okay, we are almost there. In that note, I will see you guys tomorrow, and I'll post the homework tomorrow morning. Okay, thank you for your time, and don't work too hard. Okay, I'll see you guys tomorrow at 7. Bye. I will stay behind if you all have any questions. Okay, pleasure. Okay, don't be too stressed. Do your homework and you'll be
Thank
fine.
you.
Okay, bye.